Thank you all for joining us for Slithering into Our Hearts, How Battlesnake Made Us Better Developers. This track, the beginner track, is sponsored by GitHub. They are very nice people, and we're super stoked about just them in general, honestly. Okay, so we have Erika Burdon and Scott Small. You can, yeah, let's do applause. Degree from UVic and has over 15 years of experience as a developer working in the higher education, performance marketing, and data analytics industries. He is currently a systems architect at Redbrick. When he's not hacking away on a project, he can be found globetrotting, with over 25 countries explored across 4 continents. Erika is a recent grad from UVic, from software engineering, currently working as an EIT at Redbrick. With a special interest in startups, small system design, and performance, she's always interested in coffee and exploring new technologies. So please welcome Erika and Scott for Slithering into Our Hearts, How Battlesnake Made Us Better Developers.
All right. Thank you, everyone, very much for coming. Wow, that's loud. Coming out on this beautiful day. We're really excited to be here, and we're excited to, of course, teach you about our Battlesnake. So we've got a jam-packed presentation today. I'm going to talk for about 10 minutes and give some background information. I'm going to talk about what Battlesnake is and our personal and company involvement with the event. We're going to talk about why we find the Snake game so interesting and why we keep coming back to it. And of course, our office environment leading up to the event. Then Scott's going to jump in with a technical breakdown of Robosnake 1 and 2. We're each going to jump in and talk a little bit about what went wrong with our snakes and tie it all together with how it made us better developers. At the end, we'll have about 10 minutes or so for Q&A, and I'm looking forward to Slido for that, so should be good. All right. Now, before I get into the good stuff, I have to plug Redbrick a little bit. Redbrick is a company based here in Victoria. It was founded by another pair of UVic grads back in 2011. It's got 2 primary divisions. It's got its publishing division and it's got its software division. And the software division has built some proprietary ad tech to help maximize its revenue through its ad technology. Our digital publishing properties have about 1 million or 15 million active users monthly, and our primary software has about 1 million. Right now, we're about 55 people, and we're still growing. We're constantly looking for people, and right now we're hiring for developers and business, and every semester we have co-ops. So if you're looking for work, make sure you come talk to Scott and I after our talk or at the networking event. Right, so Battlesnake. Are you all familiar with the classic arcade game of Snake? Yeah? Right, so you've got the head of your snake, you've got your body, and you've got your tail. And you've got a game board of variable size, and you're trying to, it's basically a survival game. There are little bits of food on the board, you're just trying to chase the food, eat the food, you get bigger. There's a few ways you can die, and that is you hit the wall, you go in a circle and you hit yourself, or you basically just starve. Battlesnake is a variant of this game where you can have multiple snakes playing on the same game board, which means that you're competing for the same resources, the same amount of space, the same amount of food. There's also a couple of new ways to die. You can hit another snake 2 different ways. If your snake body hits their snake body, you both die. If your snake head hits their snake head, only the smaller snake dies. So you can kind of attack and take out other players in the game. And the third component of Battlesnake is, of course, the event, which is put on by Send With Us, the same lovely host as the event here today. Since its humble beginning, actually in this same lecture hall a few years ago, it's become BC's largest programming competition. And it's pretty cool, because it's not just for professional developers like Scott and I, it's for developers of any skill level. So the dev who just learned how to write Hello World in Python can come out and have an awesome time. So we've been one of the sponsors for the event for 3 years running now, and possibly 2019, we're still waiting to hear back on that from various people. We've also had team members compete independently in the event over the years, before and after they were with Redbrick. And I think it's pretty cool. Back when Battlesnake was more of a black box, we actually made a contribution to the code base, which I personally think is pretty neat. So kind of getting back into the Battlesnake event, what it is there's two main pieces. The Battlesnake main event is when every snake in the house basically goes together in a one main match in kind of a round-robin elimination style game. But then there's also mini games throughout the event where you go up to companies and you try and get these smaller prizes throughout the day, which is what Redbrick did. We put on the bounty snakes. You come up to our table, you fight against our snake, and you try and win. And that's basically what a sponsorship is. And I wanted to point out that we didn't really have a back channel with Send With Us. We didn't have some sort of insider knowledge on how to make our snake win, because our snake had been known for being unapologetically tough. We had a couple of very determined people come up to our table and really ready to beat us, and they did, they won. The fun bit about the minigame for us is that we get to define the rules. We get to define how big the game board is, how many food is going to be on the board, if there's any food at all. We get to decide if your snake keeps growing or if it keeps shrinking. That's the sponsorship. So as a competitor, that means, again, you can come up to our table, you can go into the main event. And also Redbrick, people at Redbrick, they couldn't compete against our snake to win either. So again, just to kind of even out the playing field, that's the Redbrick involvement. So again, we've been into the game for 3 years and we want to keep going with it. And we kind of gave it a good think, and why do we find the game so interesting? We kind of talked on about it, and I think what it boiled down to was that Snake is a very, very easy game to understand. It's just survival. It's just a high score. You want to live as long as you can. But especially when you come to program it and make it AI, it's very difficult to master. There's 100 edge cases that you didn't even think about that crop up on the day of, or at least you have to be prepared to handle those on the day of. And we're not the only ones who find this game so interesting. Just a cursory Google search returns thousands of results. We found a couple of cool ones. One is college-level AI courses. Now, to be fair, they're focused on the actual algorithm, but they're using the snake game as an example. The one we found was a paper using various A-star algorithms to try and beat the game. Another one we found was, again, in kind of the paper style, is dev communities. And they're using, the one example we found was using various task prioritization decisions to decide if they're going to take out another snake or not. We found on GitHub numerous different solvers. A cool one we found was using Hamiltonian graph cycles and other kind of like deep math graph theory to win the game. And finally, a really neat one was there's 101 developer technical blog posts out there. There's no shortage. And we found one that was beating the game using neural networks on the Google Cloud platform. I thought that was pretty cool because in-house we use Amazon Web Services for all of our cloud, cloud tooling. So it's again, in a problem space we're already really familiar with, it's cool to see other technologies be applied to it. And it's not just us Redbrick developers who are interested at the company. I think everyone got involved with Battlesnake when the time came around. So back in February, we were given 3 days to work on whatever we wanted, and everyone got involved. We had the marketing team come up with some awesome prizes for a game. We had the graphics team come up with a really cool looking snake, I think. And we kind of had a little bell. We had a little buzzer that went off at about 3 o'clock every day, and it was a quiz. It was a Battlesnake quiz. Some of them were pretty simple. We had a graphic here, which basically was, depending on which snake you were, what would you do in this situation to live? We also had some more deep theoretical questions that spurned like 2 days worth of conversations. So Battlesnake at Redbrick is more than just the snake that we created. it's really everyone rallying behind to make the coolest game they can. So with that, I'm going to pass it off to Scott, who's going to get into the deep Robosnake technical breakdown.
All right, thank you, Erika. Hey guys, I'm Scott. Today I'm going to talk to you about the Redbrick Robosnake. So Robosnake was our bounty snake in the years 2017 and this year, 2018. In 2017, Robo went 42 wins and 3 losses. In 2018, it went 71 wins and 3 losses. It got a reputation for being what we call unapologetically tough. And we weren't actually trying to go out and build, the toughest snake possible. We wanted to give our prizes away. We wanted to build something that people can beat. So I am happy that there were a few people who did manage to beat it. Some of the design goals of Robo were we wanted to have a snake that's still above average difficulty because it is a sponsored snake, but not so hard that you just get frustrated and give up because it doesn't become fun anymore. The other thing is that we didn't want to use any gimmicks. We didn't want to do like a Tron snake or use a non-square board or have any of these other weird gimmicks. We just wanted a straight up like one-on-one fair match, mano a mano. So Robosnake's written in a language called Lua. Lua is really cool. It's an embeddable language. We use it for a lot of things at Redbrick. It's super fast, super scalable. Part of the reason that we went with Lua for Robosnake is because we were familiar with it, but also because we wanted something that we know is going to be fast and scale really, really easily, because there's going to be a lot of people practicing and playing games against it. So let's talk about some of the things that you need in order to build a Battlesnake. Well, you really just need 2 things. First of all, you need an arena or some kind of game board to run matches on. And secondly, you need 1 or more enemy snakes to test against. Now, the story of Robosnake really starts around Christmas 2016. I figured, we'll have a couple months to build a snake. So I went to go download the 2016 game board. I don't know if it was open source or not. Maybe it was. I could not find it. I looked all over GitHub. I couldn't find the thing. So that was a bit of a roadblock. And then obviously the 2017 API didn't exist yet. So all the other snakes that people had gone and published on GitHub were using the previous year's API. So I thought, all right, I'll just go and write my own game board. It can't be that hard, right? And this is what I came up with. I called it MOJAVE because the Mojave Desert is famous for its rattlesnakes. And I had the name before Apple took it. It's also written in Lua. It's using a game framework called Love2D, which is really cool. If you're into game dev, check it out. It's available for Windows, Mac, Linux. It was very quick and dirty. There's a little JSON file you could go and edit and put your snake URLs in there. You could pick, which rules, which version of the API you want to run your game under. It was really, really hard to build because there's so many little quirks and edge cases that you got to think about when you're actually building the Battlesnake game. But it was really good to kind of get that background knowledge and have this system that we could use for testing. So going back to Robosnake, let's talk about our win conditions. We went with a 17 by 17 game board. The reason for that is because I found a YouTube video of a 2016 game being played, and that was the size of the board. So I just figured, okay, we'll go with the same thing. I went with a 1-second API timeout because that was what was in the 2016 API. I went with 10 food on the game board, and that was really an arbitrary decision. In 2016, in this YouTube video at least, food was just randomly spawning all over the place. Whereas in 2017 and 2018, there was a fixed amount of food on the board. So I just went and said, okay, 10 sounds like a good number. Let's go with that. And last but not least, a one-on-one match, because I think, 1, that's fair for a bounty snake, and 2, because our algorithm requires it. And I'll get into our algorithm in just a minute here. So let's talk about the initial design. At first I thought, oh, building a snake, yeah, this is going to be a walk in a park. So I coded up some little modules. I found it's this A-star pathfinding algorithm library. And I said, okay, well, I'll just look for, the other snake's head, and I'll look for food if I'm hungry, and I'll look for an empty space in the board if I want to run away. And yeah, this isn't that hard. And I coded it all up, and then I downloaded some other snakes on GitHub and got my butt kicked just over and over and over. And I said, wow, okay, this is actually not easy at all. And I need to think about how I'm going to do this. So I went on Google and I typed in snake game algorithms and Tron game algorithms. And as Erika was talking about earlier, there's a ton of great material out there about it. And something that caught my interest was a family of algorithms called Minimax. So the Minimax algorithm, and I'm going to get a little bit technical here, is a means for selecting the optimal sequence of strategies in a two-person zero-sum game. So a zero-sum game is a game where rather than each player having a score, you can think of the game board itself having a score with 0 in the middle. And as one player gains the advantage, the score goes positive, and the score goes negative as the other player gains the advantage. So my advantage is equal and opposite to your disadvantage. So Minimax algorithm states, for every two-person zero-sum game with finitely many strategies, there exists a value V and a mixed strategy for each player, such that, given player 2's strategy, the best payoff possible for player 1 is V, and given player 1's strategy, the best payoff possible for player 2 is negative V. What does that actually mean? It basically means that my best move is not to take the move that gives me the highest score. It means my best move is actually to try to take away your best scoring move. So how do we go and implement this in code? First of all, we need to come up with something called a heuristic function. And a heuristic function is something that takes the current state of the game and comes up with the score. So if I've got a Battlesnake board and I've got a snake over here and a snake over here and some food here and some food here, how do I take that and turn it into this number that could be positive or negative or 0? That's what the heuristic function does, and I'll get into what Robo did for that a little bit later. Then we implement our recursive minimax function. So we get all the moves for player 1. For each of those moves, we play that move out, so we simulate it. Then we go to player 2, and we play all of its moves out and simulate those moves. And we keep going back and forth until we reach an endgame state. So I'm dead, or I'm trapped, or the enemy's dead, or the enemy's trapped. Or we've recursed so many times that we're worried about running out of time to return our move. And what happens when you do this is you start to build a tree. So does everyone remember their algorithms and data structures course? So you have this tree that gets built out, and at the bottom of the tree are all of the leaf nodes. And on all of those leaf nodes, those are the final game states. And for each of those game states, we run our heuristic function and come up with the score. Then we walk backwards through the tree. And we start at the bottom and work our way back to the top. And if it's my move, I take the move with the highest score. But if it's the enemy's move, I take the move with the lowest score. And in doing that, that's kind of how we go and predict the future. So let's walk through a little example here. So imagine that Erika and I are playing a game of tic-tac-toe. So I'm X, she's O. And we're going to have a really simple heuristic function. If there's no winner, the board has a score of 0. If X wins, the score is plus 10. If O wins, the score is minus 10. So starting from position 1, there's 3 places where I can put the X. One of them leads to my victory, so that gets a plus 10. 2 of them is indeterminate, so the board score is 0. So if we pick an indeterminate state, now it's Erika's turn. She has 2 possible places to put the O, based on where I put the X earlier. One of those places leads to her victory, giving the board a score of minus 10. The other one, still indeterminate. So if we pick 2 indeterminate moves, it's my turn again, and the only option I can take leads to my victory, resulting in a plus 10. So now we walk backwards through the tree. Well, it doesn't matter which state is picked at the bottom because they're both plus 10. It's my turn, I'm picking the highest move. If we go back up a level, and it's Erika's turn, we're going to pick the move that results in minus 10, meaning we can never enter the state where I win and get that plus 10. So then we go back up another level. Similarly, there's a state that I can take that's plus 10, so we're never going to enter the state where Erika gets to take the minus 10. So let's talk a little bit about the game state. In order to make Minimax work, like I said, we have to play all these moves out to end up with our final state. So in order to do that, Robo needs to be taught the rules of how Battlesnake works. So we actually need to basically build a copy of the Battlesnake game board into Robo, which is why doing all that work on Mojave earlier really helped out here. So I know that if I'm passing over some food on turn X, then my length increases by 1 on turn X plus 1, and I can no longer safely move into my tail. If I'm not passing over food, my health decreases by 1. My head and tail are moved to new positions, and moving into a wall or another snake's body results in my death. And whoever's the current player, these rules obviously apply to both. So you switch between yourself and your opponent every time you go back up through the tree. And now let's talk about the heuristic, which I mentioned a little bit earlier. This is the most important function in all of Robo. If you don't take anything else away, take this away. The heuristic function, like I said, is how we determine for some game state what is that score of the board, because that's going to determine whether we pick that state or not. So what are some of the things we look at? Well, if my health is at 0, or if there's no moves available from my current position, then I'm dead, so we give it a minus infinity score. Likewise, if the enemy's health's at 0, or if there's no moves from the enemy's current position, then we're going to pick a positive infinite score because I've won the game. The other thing we're going to look at is a flood fill algorithm. And flood fill is just a way of saying when I'm on a grid, how many spaces can I see from my current position without getting blocked by a wall? So if my length is, let's say, 5 or 6 or 7, and I can only see 3 free squares, that means I'm probably going to die in 3 moves. However, it's not guaranteed, because maybe the only reason I can see 3 squares is because I'm being blocked by the enemy. But in those 3 moves, the enemy is going to move away, and that space opens up. So it looks like I might die, but it's not necessarily a guaranteed death. So we're going to score the board, high or low, depending on whose turn it is, but it's not going to be an infinite score. So we'll always take the infinite score, guaranteed victory, over a probably but not totally sure victory. Other things we look at, which are pretty standard for a lot of battle snakes, how close am I to food right now? How hungry am I? We look at the distance to the center of the game board as well, because I was originally developing the snake for the 2016 rules. In 2016, they had these gold coins that would appear in the middle of the game board. And if you collected all the gold coins, you'd instantly win the game. But this also had the side effect of if we were hanging out in the center, it would push the enemy out to the edge so we could pin them up against the wall. So some of the challenges that we had in 2017 was that first of all, the API changed between 2016 and 2017. One of the things that they did was they removed gold, they removed walls. They also changed the coordinate system. It used to be north, south, east, west, and it changed to up, down, left, right. So what this meant was that 2017 and 2016 snakes couldn't play in the same game anymore because they expected different API responses. So what I had to do was, and I was glad I'd written my own game board now, I could modify Mojave so that we could play using the 2017 rules, but keep using the 2016 API for communicating with the snakes. And that way I could still practice with other snakes that I found on GitHub. The other issue was that the API timeout got reduced to 200 milliseconds. There's something about, a human player in 2016. Some rumor about that. And so they made the API timeout really, really low. And that caused problems with Lua. Lua uses a garbage collector that runs periodically, and when the garbage collector ran, then we'd go over time, and we didn't return our move in time. So we had to drop the Minimax recursion depth, not look ahead as much, which was a little bit frustrating. But then, fortunately for us, on the day of the competition, we got told, oh, that actually doesn't apply to bounty snakes. You can still have a 1-second timeout. So we ended up getting lucky. So now let's skip ahead a year. Let's talk about what happened this year. This year, we put out Robosnake 2.0, or as we named him in the game, Son of Robosnake. So the design goals behind the Son of Robosnake, we had 4 goals. The first was that we wanted to play games faster. Original Robosnake, if you remember from playing him, was very, very slow. And it would, because of that 1-second timeout, it used the full second. So games would go on for a stupidly long time. And it kind of frustrated a lot of people. The second thing was that we wanted to play aggressively. Original Robo played a very defensive game. He'd hang out in the center of the board and then try to eventually pin you up against the wall. That also meant games took a long time, even if they were being played quite fast. So we figured, well, if we can just, do a headshot and kill the enemy right away, then that makes the game go a lot quicker. Personally, I wanted to beat some of the snakes that beat us in 2017. And last but not least, we wanted a better logging and debugging ability because we didn't have good logging and debugging, which when things did go wrong, it was very difficult to find out why. But first, I put a big update out to MOJAVE and open sourced it. And I'd like to think that I've invented the prettiest Battlesnake board in existence. Yes, this is a bloom filter. I challenged Send With Us this year to make something that looks just as pretty, so that I don't have to. So if you want, you can download this. Here's a link on GitHub. The big reason for doing it is that it supports 2016, 2017, and 2018 API snakes all in the same game. So you can play the best of each year on the same game, on the same board. It'll know which version of the API to talk to that specific snake. And you can customize just about everything: the width, the height, the API timeout, the game speed, the starting length, how much health is lost or restored by food. You can pin the tail to turn it into a Tron game. There's a lot of functionality in there. But the coolest thing of all is that because MOJAVE is written in Lua and Robosnake's written in Lua, I've actually built Robosnake directly into MOJAVE as a computer opponent. So you don't have to set up your own server. You don't have to know anything about Lua. You can go download a copy of MOJAVE and you can play your Battlesnake against Robo without having to set up a server or anything. You can also play as a human, which is really cool. You can add a human player to the game and control it with the arrow keys. So if you ever wanted to try your hand against Robo personally, or any Battlesnake for that matter, you can do that. The reason for doing it, well, it's kind of because I could, but also the official game board. My laptop here doesn't have a lot of memory, so the official board would crash and run out of memory a lot. My laptop just doesn't like Docker. But enough about that. Let's get back to the Son of Robosnake. So how do we make him play aggressively? I actually tried when I was building Robo in 2017. I tried to make him play aggressively, and I really struggled. I just couldn't get it to work. I wasn't sure why. I was busy. I'm working on the Minimax algorithm, and I just couldn't get it to work. So that's another reason for going with the keep to center. And I finally figured it out in 2018 because I had some more time, dug back into the code, and it ended up being really obvious. And I'm like, oh, why didn't I think of this before? There was a major, major design flaw in our Minimax algorithm implementation. And if you've been listening to my explanation and you know a thing or two about algorithms, you might have already figured out what it is. Does anyone want to take a guess?
It doesn't take into account simultaneous turns?
Exactly. So the Minimax algorithm is designed for games in which players move sequentially. I move, the enemy moves. I move, the enemy moves. But in Battlesnake, all the snakes make their moves simultaneously. So Robo would assume that the enemy always knew our move before making its own, and thus it would always attempt to avoid a head-on-head collision. Likewise, we'd try to avoid head-on-head collisions just by nature of our implementation of Minimax. Once we realized that that was the problem, it was really easy to fix. If it's the enemy's turn, instead of taking the current game state that Robo just manipulated, take the game state as it was at the start of Robo's turn, before Robo made its move. We both apply our moves to that game state, and then we can update the game board. And once Minimax was fixed, there were a couple small code changes we had to make to Robo after that. We updated the game state logic when looking ahead to teach it that head-to-head collisions are a thing that you can do. And then we updated the heuristic to say, rather than making the center of the board a very favorable space, make the enemy's head a very favorable space so that we target the enemy instead. And once we did that, bam, Robo got really, really aggressive and started doing all these headshots. So here's an example. This is what Robo was doing in 2017, the original version. So you can see that there's two snakes, and blue makes its move first. Orange is making a move with previous knowledge of what blue did. This is what Son of Robosnake does, where the blue snake and the orange snake are making their moves simultaneously without knowledge of what the other snake did, which means you can result in these states where the two snakes have a head-on-head collision, and then we apply the logic to determine who won and who lost. But Son of Robosnake wasn't all about fixing bugs. We wanted to add a few new tricks as well. There was one snake that I found on GitHub. I believe the name was called B-Snake. And that was a really, really tough snake. We weren't getting it every single time. So we thought about it, and we figured out some ways that we could do better against it. So the first trick we implemented was, if we're smaller, actually I think that's a typo. If we're equal to the default starting length, we want to go for food before becoming aggressive. So rather than try to duke it out with this other snake that's also coming after us, if another snake's coming after us right away, we're going to run, go for some food, grow by one, and then go after it, because now we're the bigger snake and we have the advantage. And if the enemy continues to prioritize aggression over food, that causes early kills. Second change we made is we use the enemy's current direction to make a prediction about where they're going to move next. So if the enemy moved left on their previous turn, for example, we're going to assume that they're going to go left again on the next turn. And in doing that, we can take that square and we can give it a higher weighting in our heuristic that's higher than the other squares around the enemy's head. And what that caused Robo to do is start executing diagonal attacks rather than just trying to drag itself along the side of the other snake. Last but not least, because we're chasing the enemy's head now, and instead of keeping to the center of the board, we're now vulnerable to what original Robo was doing, where we could get pinned up against the outer edge. So we updated the heuristic and said, if your head is in the outer edge of the game board, we're going to weight that board very, very unfavorably. We're going to give it like minus 25,000 or something like that. So we avoid the edge of the game board unless there's absolutely no other option. Performance enhancements. We wanted to make Robo much, much faster. And we thought that the algorithm was the issue, but it turns out that wasn't the case. So I downloaded a Lua code profiler, ran it against Robo, and we found 3 things that we could change to speed it up. First was our flood fill algorithm. We don't actually need to check every single square on the board to see if we can see it. Really, we just need to check our current length plus a little bit of padding room. So that sped things up quite a bit. We also had what's known as a deep copy function. basically when we're going and running our Minimax and creating these new game states, we take the previous game state, we make a copy of it, and we modify it. And then we copy that game state and modify it, and so on and so on. So we're doing these what they're called deep copies. And the Lua function that we were using copies something called metatables, which is a property of Lua that we don't actually make use of in Robo, but it's very slow to access. So that caused us to slow down quite a bit. So we removed metatable copying from our deep copy function, and that sped things up a lot. Last but not least, we had our original logging function had something in there to pretty print coordinates. And when we turned off the logger, the pretty printer was still running. It would pretty print the coordinates and then call a function that no-opt. So yeah, that was a little brain fart there, but that was an easy one to fix. And it turned out to be a really, really good thing that we focused on performance and made those changes, because unlike in 2017, the bounty snakes were actually subject to the same API timeout, 200 milliseconds, that every other snake was subject to. We couldn't change it. So Robo played its games much, much faster, and thank God we did, because otherwise we would have lost every game. And with that, I'm going to turn it back over to Erika to talk a little bit about her project, which was our improved logger.
Right, so thanks, Scott. One of the things he mentioned was that we wanted to improve logging of Robosnake, or son of Robosnake, sorry. One of the challenges of working on a project like Robosnake with such a deep heuristic and such technical algorithm is that it's kind of hard to have a bunch of developers working on the code at the same time. It's kind of a too many cooks in the kitchen type situation. So while, of course, we worked on the algorithm together, my major contribution to Robosnake was this logging. I just wanted something super simple. I wanted to be able to go back into the logs and be like, there's Monday's game. I want to have a visualization, and I want to be able to go through the game step by step and kind of infer what happened. I don't need to know every little decision that the Robosnake made. Now, around the same time we were building this last year, there was a competitor snake who came out with a web app who kind of did the same thing, but there were two reasons I didn't really want to use that. A, it was by a competitor. It was open source, to be fair, but it was also our code. I wasn't quite sure. I felt really bad about using someone else's code to make my snake better. And the other half of that was that I wanted to do it myself, the same way that Scott built his own game board. Is I wanted to build my own logger, kind of see what would happen and see what the challenges were. So this is an example image of the output of the logger. You can see that I used very beautiful ASCII text to recreate the game state on every turn. The game state being the size of the board, how many food were on the board, the position of the head, the tail, and the body in between. It also lists just the name of the snake, the health, and the length. The point was, so this is all just user input, and you just play through. You could skip ahead 5 turns, you could skip ahead to the end. How it worked was it was tightly integrated with Robosnake, so the first half was written in Lua. And this little data collector would pick up key points of the game state and key points of the Robosnake decision, and it would punt it over to another server who would just take that data and write it to a plain text log. The second half of the program was Python, which is just a very souped up file reader, basically. It read the nitty-gritty, non-human readable details and produced a beautiful image. And just to touch on that, the mechanism, the punting mechanism from Robosnake to the recipient server was just FluentD, and this is basically just socket logging. It used a UDP mechanism. If you're familiar, it basically says, I have a message to give you, I'm just going to send it out and hope you get it. So we didn't have any sort of handshake mechanism to be like, hey, I have a message for you, are you ready to receive this message? Yes, give it to me. None of that. There were some challenges with this logger, and we tried to be good about it. We tried to get it up and running 3 or 4 days before the event, but we kind of had a series of cascading failures. The first one was, you're going to run into this 1,000,000 times in your career. It worked great on my machine. There were no problems on my laptop. The problem was that our developer environment was different than our production environment. On dev, we knew we weren't going to get 100% performance out of our machine on Robosnake. So we didn't really care that we had the two servers, the Robosnake and the recipient server running on the same machine because, whatever. But on the day of, we wanted to make sure that Robosnake could squeeze every last drop out of the Amazon cluster we had given it, which meant that we wanted the recipient server to be out on its own, which was fine anyway because we were going to be looking at that data retroactively. We didn't need it to be on a super souped up server. We couldn't get them talking to each other. Even with the UDP, just here's a message and take it, the other guy wasn't picking it up. But even if we had gotten those two working, if we had gotten them cooperating, there was a second problem where I'm of the personal Git flow belief where you commit fast, commit hard, commit often. So very, very small commits. The problem with that was that my logger had 99 commits, had 99 conflicts against the master branch. So Scott was moving at 1,000,000 miles an hour, and my Lua, my data collector, was so tightly integrated with his code that he would merge his changes into master, and I would try to work mine in there too. And I just had conflicts on conflicts. It was infinite. Finally, there was a fundamental flaw with the logger. You receive data from the Send With Us server for as long as you're alive. So, you're going along, you play, here's the new game state, here's the new game state. If you win, or if you die, you're not playing anymore. So it had no data to give you. This meant that the logger could only replay up to n-1 moves. So really, you're still kind of guessing who won the match, and hopefully you have it written down somewhere that you won, and you can kind of see the lead up. To their credit, the endpoint came out about 2 weeks before the event, which gave this final game state information, but I wasn't able to integrate it into the logger in time. And I believe the most heartbreaking thing about not being able to get any of this working was that we did not have immediate feedback on what went wrong with Robosnake on the day of, which Scott is going to talk about.
So, there was something different in 2018 that was different from previous years, and that was the Bounty Snake tournament. So, after the main Battlesnake event had taken place, Send With Us went and announced, they said, hey, we're going to take all of the bounty snakes with all their different code and their different win conditions and assumptions about how the game and the arena is going to look, and we're going to throw them all into a single match and see what happens. And if you're the last one standing, you get this really cool trophy. And I'm like, oh my God, we're not designed for that. So Robo was the third snake eliminated, amazingly not the first. Any guesses as to why? And I think it's going to be painfully obvious. We did manage, fortunately, to get a beautiful kill against Giftbit Snake. Is there anyone from Giftbit here today at all? No? All right, well, they went down first, we took them out. So at least we had that, to brag about. So how do you think the Minimax algorithm works when there's more than 2 snakes in the game? Or more specifically, when there's more than one enemy snake? Well, it really doesn't. I mean, you could try to do something where, you're predicting the moves of every single snake in the game, but if there's 12 snakes on the board, you'd have to recurse 12 times to look 1 move ahead. You'd have to recurse 24 times to look 2 moves ahead. That's going to get really unwieldy and really expensive really quickly. So it really doesn't work. So how does Robo cope with that? Basically, we have a little hack in our code that says, if for some reason there's more than one enemy snake, more than 2 snakes in the game, we're going to take the enemy that's closest to us, that's the shortest distance from our head, we're going to consider that the enemy for the Minimax algorithm, and every other snake on the board is going to be turned into a static wall that never ever moves. So now what do you think happens if you have 2 enemy snakes, because this actually worked for the most part when we were testing. But what do you think happens when there's 2 enemy snakes that are the exact same distance apart from Robo's head? We hadn't thought of this. Who do you think gets picked? It turns out it's whichever snake shows up first in the game state data, in the JSON that gets sent to the game board. So I'm going to show you a couple screenshots now, and I want you to take a look in the top left corner. This is 2 moves before we died. So Robo's the green snake in the left there, going down towards the food. Behind Robo, you can see a blue snake spinning around chasing its own tail that belongs to check front. And then there's the purple snake that belongs to Send With Us. That's also going for the same piece of food that we are. Now, if you count the number of squares between Robo's head and check front's head, you'll find that it's 4, which is the same number as the number of squares between Robo's head and the head of Send With Us. So, Robo, going for food, should be predicting Send With Us, who is also going for the same piece of food, clearly the threat, over checkfront, who's just spinning around, going after his own tail. But if you look at the list of snakes, you can see that checkfront shows up first because they were added to the game first. So who did Robo end up predicting and who did Robo end up ignoring? So we made our move towards the food, and that brings you to this screen on the bottom right, where now we are much smaller than Send With Us. We're going for the food, they're still going for the food. And the Minimax algorithm says, well, if you go down, you have a 50% chance of death. If you turn right, you've got a 50% chance of death. So it doesn't matter which move you pick, you've got a 50% chance of death. So we have another fail-safe in the code that basically says, if Minimax can't return a best move because all moves result in the same board score, which is a negative infinity, you say, well, YOLO, we're just gonna pick one at random. And we went for the food and we died to Send With Us. Sad. And with that, I'm gonna turn it over to Erika one last time, who's gonna talk about how this whole experience has made us better developers.
Unfortunately, we don't have a good answer for you because it's kind of hard to describe how all this together, in the whole big picture, makes you a better developer. You know, we sat down and we gave it a good think, and I was the only one who came up with an answer, which was my personal Git flow. I reworked it, so I tried to avoid the 99 commits. I also learned how to squash. If any of you learn Git today, and if they talk about squash, love it, because it is the best. You take 99 commits and you drop it into 1. So when there's a conflict, you only have to check once. It's awesome. Similarly, because I now learned squashing, I had a much easier time understanding Git rebase. Git rebase is a terrifying thing if you don't know what you're doing. But again, once you kind of work into your flow and get used to it, which I have, you kind of love it. And finally, I kind of go more not quite pinpointed. I'm able to identify those tight couplings a little bit earlier, the way that I had the data collector too closely integrated, collecting unnecessary information about Robosnake. I can kind of spot that now in my current work. I'm like, hold up, that's probably going to cause a problem in a month or two when we want to refactor that, as we always do. And so I just don't do that anymore. And kind of moving more into hand-wavy territory, general betterment. I feel that we spend so much time as developers constantly building our skill set, constantly getting better, constantly learning, making sure we're on top of the latest tech stack. We never have a chance to just play, to just go. And something like Battlesnake is a great time where you have a skill set, you could just use it. There's still challenges. There's still all the edge cases, and there's still all the other players in the game, literally. And of course, the algorithm that you're trying to figure out, but now you've got a really, really solid foundation. You have something to work with, and it's fun. And kind of tied into this is any chance that you have to articulate a new problem and to articulate a new solution, it's an opportunity you should take. Especially an event like Battlesnake, where you have devs whose skill levels are across the board. You have people at the event who aren't even developers. They're just like the Redbrick marketing team. They're just there to support, but they kind of want to know what the hell you're doing. So being able to describe to them is really refreshing, and this is a really good skill to continue building up. We welcome feedback on how you think this made us better, because unfortunately that's our answer. But with that, we're going to pass it over to Slido for some Q&A, because I think we hit the nail on the head for 10 minutes of questions. That's, whoa, not bad.
Yeah, thank you. Okay.
So, looks like this is the top one.
So we got, how in the world did you guys find the time to work on this alongside your regular job? I don't have a social life between Christmas and Battlesnake. Yeah, most evenings I'm just like hacking away on the laptop and yeah.
And to add to that, at Redbrick, we do have 3 days every quarter to work on whatever we want. We're very lucky at Redbrick, and I think we all dedicated our last 3 days to Robosnake this past year.
We have, do you program snakes in Python just so it's thematic? That's awesome. I like Lua personally. But for those of you that were around in 2017, we had some of our team put in a competition snake that was called Better Than Alexi's Snake that went on to win that year. And that was written in Python. So at least some members of our team do. And then we have, Minimax assumes both agents are perfectly rational. Are adversaries with stochastic behavior is problematic? I don't know what that means. I read a blog online. It made sense, and I said, okay, I think I can implement this in code. And it seemed to work. So there's your answer. And, oh, we got one more. What would you say is the best way to have fun as a beginner in Battlesnake? Do you want to start?
So I think you really can't take it too seriously. Like, it's a fun event, and I haven't won anything at all in my entire experience at Battlesnake. But the point is that I think last year there was 600 something people at the event. So there's a ton of people that you can just go, talk to, socialize, talk about the problem, and you just kind of hope for the best. I think that's, and of course I think at Redbrick we also had a bunch of fun with it. Again, because we had a lot of people involved, but it's just a game. It just, I don't know, why do you have fun with video games, right? You're just trying to win, you're trying to be the best.
And I think to add to that, I'd say, don't be afraid to go and challenge like really tough or really advanced snakes. We had someone came by who stopped at our booth like, 7 or 8 times was it? And yeah, that was pretty fun to see them, come and challenge us and say, oh, I'm gonna get you next time, and then go and make a bunch of changes and then come back and challenge us again. And don't forget, there were 3 people both years who beat Robo, different people. And I think a couple of them were snakes from the beginners division, which was actually pretty amazing that they were able to beat us. So, it's amazing that they can do that. Don't think that just because you're a beginner and you don't have a lot of experience that you can't go and take on a really tough snake.
Yeah, a challenge being sometimes when we're trying to build the perfect snake, we're thinking of all these really, really weird edge cases that sometimes we forget the basic ones. For example, what do you do when there's more than one enemy snake on the board? We just forgot.
Yeah. Oh, that's a good one.
Come talk to us.
Yeah, the question is, can I have a co-op position with you all? Yes, we have an active co-op program, so yeah, if you're interested, come talk to us.